Hello and good evening, morning or afternoon, and welcome to the sixth and final part of the Block C in-depth explanation series. So this time we'll be going over the visual proof of concept, or the visual vertical slice, however you like to call it. So that's the thing right here. Yeah, let's jump right into it. So this whole thing was made to give an idea of how the visuals would be and what kind of level of quality I was aiming for. So in the end, I'm quite content with how it ended up, except for those normals here on the geometry. They're still messing up a little bit. But yeah, let's just go over the system. So it can mainly be divided in 3 or 4 sections, debatably. The fourth one being this one, which is the placement part, but we're not going to bother about that too much. So the first part is the input part, which is this part here. To actually make that network view a bit bigger. So there we go, we have our input part, the importing of the assets. So you can see here in the viewport, these pillars are actually imported as models from Maya. So to kind of showcase, hey, the system can use things from other software. So that's what we're doing here. And then here is where the main modeling magic happens. So let's first go do the input. So we start off with a very simple line. This one I think is 20 Houdini units long, or 20 meters. The first thing I do is resample that line and use this again using a segment thing. So a resample node accepts a attribute to set the segment count, or minimum segment length. In here I just add the segment length using this here. So I just have a slider that I can make bigger or smaller. So you can see here that the amount of points is changing. Let's actually turn off the grid so it's better visible. You can see here the amount of points is changing. And what happens is that if the amount of divisions is an odd number, for instance 3 or 5 or 1, then 1 is added. This is to make sure that well, an even number remains. I use certain modules for this final result, and I wanted to make sure that I always have the correct modules, which can only happen with even point numbers or even segment numbers. So what I then do is I group some stuff. So here I have 2 groups, a middle group and an outer group, using the neighbor count expression. In here I then keep the middle, add some groups for various parts, transfer them over here, and then here add some more groups. So basically in the end we end up with a line that has every other point grouped to large points and the points in between grouped to small points or small pillars. These are used in the pillar placement, which we have in the assets here. So the way I exported the pillars is through a bottom section and a top section. This was to make sure I would be able to later make them as long as I would need. This could have been done differently, but for this time I chose to use this method. So this is done for both large pillar and small pillar. So this little poly extrude here makes an additional segment here. So if you go here before, it's just this, and then here it's made a bit longer to accommodate for the top part. So this pillar editor thing here is a small subnet that just adds groups. But in the case of the large pillar, it does a bit more. So you can see some parameters appeared because the pillar type was set to large. And on the outside, you can't really see a lot. Even if I turn on the points, you can't see a lot. But if we kind of zoom in and go in here, we can see 2 points have appeared that weren't there before. There we go. So they weren't there before. So the reason I add these points is to place arches later. So if you go in here, it's a very simple setup. It just uses an add node to make a point and then place said point at a certain location. It is then merged. As you can see here, they're merged with the rest of the geometry, and they're just staying there until later notice. So that's the asset importing. Here I have a switch to, well, switch between the types. So I had some test geometry. So here you can see just simple tubes for the pillars, which I later switched to these. So moving on to the first section of the modeling. So I divided the whole geometry into a couple of layers. So the first layer, which are the bottom arches, the second layer, those are the more complex arches. Let's actually just pull it up here. Here we go. So the second layer, first layer, can't really see the arches right now. Actually, let's do this. So the first layer, second layer, ceiling layer, and last but not least, the ambulatory. I'm not sure if I'm pronouncing that right, but I hope I am. So let's first go to the place pillar. So this is just a simple copy setup, and the most notable thing here is that I separate the arch points. So you can see here those larger pillars are copied onto the points, and here I separate the arch points. Those are then used in this section here. So this is actually pretty interesting. So here we have our arch. This is just a simple sweep. It sweeps a cross section around the curves that are placed. But this is where it gets a bit more interesting, because I take the cutting shapes from those arches, I extrude them a little bit, and then cut them out of the wall geometry. So we have that here, and I just cut it out with this as an end result. I use a little tool for this, a for boolean. I found that the boolean doesn't work as well in every scenario, because sometimes it has a maximum cache for the amount of geometry, if I recall correctly. I think that's the issue I was having. So I just made sure it happened in a for loop so that it would just cut everything out without any problems, and it works like a charm. So this is actually probably one of the most boring parts, the first edge part. It just takes the input lines and it makes a little rounded edge from it. Not that interesting, but wanted to have it in there for detail nonetheless. So that's the first layer right here. Yeah, as the base. So moving on to the second layer, where we have this kind of more complex looking geometry. So there's a bunch of subnets here. Most notably are the arch lines and the, I think, make wall. Yes. So let's just go over them, all of them real quick. So if you look at the end result here, let's ghost it. You can see that this makes these small wall sections in between. Here the pillars are placed. Here, like I said, we make those placement points for the pillars as well as arches. No, just arches and pillars actually, because in here you can see there's two outputs. And here we then just place the arches, sweep some shapes across it, and here we cut out the wall pieces. So let's actually go to that arch lines part. So if you go in here, so I found a new way to use a carve node, or at least a way I hadn't used it in before, to decrease the size of primitives. So if you put on a null node here to view the input, let's actually just move this up a bit so I can actually get the output from the input. Oh, that sounds interesting. So here you can see we have a line divided just in segments. Yeah, just primitive segments using that convert line node to end up with this result. I then use a carve node to individually take each primitive and kind of decrease it in size a little bit. This was a case where I wanted to use compile blocks. So compile blocks are a method to optimize your system. If I understand correctly, they basically take anything that's inside of them and make it multi-threading. So that works very well if you want to speed up your system. So here I just use it for a loop because loops are very expensive, and I wanted to be sure that I wouldn't waste too much time on that loop. So a compile block is very ideal for that. So inside of here I resample everything and group everything. So the reason I had to do this separately is because if I would use a group with range outside of it, it would not get the points like this. It would miss certain points or wouldn't group certain points. So yeah, I wanted to make sure that I had them correctly. In here I then use that line to placement points, which is just that similar setup, add points to primitive centers. and the such. I've used them before in here as well. And then we end up with a bunch of points, which are then tossed out to the output. In here we have a bit more, so you can see that we're starting off with just these lines, and in here I add some inner points. These are the pillar placement points, yes. So here we go. The placing of the pillars is just taking those same assets you saw before and just copying them. Now the make wall section is again a bit more interesting. Let's actually disable this. It uses the same setup as before. So just cutting out arches from a wall, only this time it uses it twice. So here you can see we have our cutting shapes, our wall shape, and it cuts it out. And here we again have our cutting shapes, our wall shapes, but as you can see they would overlap in this way. And I wanted to avoid that because it would mean overlapping polygons and it would kind of be a waste. So here I use the Boolean to cut it out. So yeah, very simple. And I cut out the insides as well, so as you can see here. So with a Boolean you can export a bunch of groups. And here I use this group in particular to cut out this middle part. So if you go before the blast, you can see that all this is still here. And here I just remove that unnecessary geometry. And then we end up with this result here. After that, all the arches are just merged and everything. So here we have the final result. Moving on to the second edge part, this is really just the same as the first edge. So if you go in here, there's nothing interesting happening. The only thing that might be a bit interesting is that I changed some parameters around, but that's about it. So then we get to the ceiling arches. So the first issue you'll probably see when you get to this is that there are these lines. These are normals that are not correct, so I use vertex normals for this. But when a normal node is set to a certain angle, this happens basically. And there's a very specific angle that might work, but I have yet to find it. So we're inside of the ceiling arches now, and as you can see again, one of those compile blocks to optimize a part. So yeah, right now this is kind of it's not very useful because it just runs over 2 parts, but if the start line would be bigger, it would run over more parts. So yeah, just to speed it up wherever you can. This section is kind of boring. It just places a bunch of arches which are then later used. So that's what happens here actually. So suddenly you can see the magic happens. So we start off with our arches. In here I use that same redo height as I've shown before in other videos. What this does is it loops over primitives and rescales the points according to the lowest height in this case, I think. Yes. Then I just sweep some things over it, and there you go. So this clip node here, just make sure that it gets cut off. So if you go to the sweep node, you can see that here there's some intersections. And if I click this clip node, it kind of removes them. And using a polyfill to close off the geometry. Then we get to a more interesting part. So this split node here is where it starts. This is a node that I think came with Houdini 16. It might be seen as redundant because it really is just 2 blast nodes tossed into a subnet. But what it does is it takes a group and separates the geometry according to that group. So on the right side we have our larger arches, and on the left side we have our cross arches. So when we get here, let's see, there we go. I use the up vector and the normal to make a third vector, the direction vector. Again, using that cross function. In here I then use it to move it or displace it. So we end up with this. As you might have seen before in the end result. Let's actually turn off those vectors, they can be very cluttering. Yeah, so you can see these flat parts here. Let's actually turn on flat shading. You can see these flat parts here, and I wanted to really emphasize that those large pillars are separate and that they don't clip in any shape or form. So that's why I made these, and that's what this part does. So it just makes those separate a little bit, merges everything, and then using a skin node, it moves everything together. Again, a clip node just to clean up anything that's besides a certain part. So yeah, and then a normal node to adjust those normals. So first we have this mess of a geometry, and then we get it here. So as you can see, if I kind of pull these sliders, you can see it either moves up or it doesn't do it at all. Yeah, I think when I use this angle, it shows up with render issues. So no matter what, it kind of has issues for some reason. But that is the ceiling. So now to the final part, the ambulatory. I'm still not sure if I'm pronouncing that correctly, but I'm just going to go with what I know. So again, this is a fairly big system. Yeah, it's divided in a couple of sections. So here it's again just placing arches. Here we're doing some interesting cutting and modeling, and here it's sweeping arches. So yeah, let's just go from the top. Here you can see those points that were made with the pillars earlier on. Those are imported here as well, just to place the arches. These are some cross arches. So if I actually pull up the other arches, you can see here that it starts to form a shape. And here even more. So there we go. Yes, it's still working. So you can see that it's just, I'm making a framework of all these arches. This is where it gets interesting though. So as you can see here, we're getting a body. So we're getting some geometry in here. So this is a fairly simple setup. So I just take all these arches, remove the points that are above a certain place, sort them. So I found that primitive order is very important when it comes to sorting. So if I turn on the skin node, you can see it's actually getting normal just to have it look a bit better. So let's set it to 10, I suppose, or 15. There we go. Still a bit messy, but okay. So if right now I just have that sort node, if I turn it off, you can see that the geometry certainly has an interesting look, but it's not the desired one. So what the sort node does is it just sorts by X. So if we turn on the primitive numbers here, you can see the order is in a really weird shape, but after the sort, it's just sorted along the x-axis, which is then utilized by the skin. So this skin is then put into this part. So seemingly a lot happens in here. So let's actually just have a look. So these parts are the two main things that happen. So first of all, the arches are cut out, and here a seam is made for later skinning. So let's first look at these cutout arches. Again, using that for Boolean, this time slightly modified. So what happens is we have our skin and that these arches, and in the node here, in the for loop here, I just turn it into full geometry, extrude it, and cut it out. So it's not a very complicated setup, and then just here group all the points and delete them if necessary. Yes. So that's what happens here, just cutting out that geometry to be used later. So here I clean it up a bit. So here we go, ending up with a bit more visually appealing result. Then on the other side we have our make seam. So this was necessary to make sure I could make a bridging part between the first layer arches and the ambulatory. So here we have our placement points again, adding some normals. So I think this is again that visual glitch. Yeah, it is. So here we go, we've got some normals, and here you have 2 points inside of each other. And using a loop, I just place some arches. Now the reason I put it in a loop is because sometimes I need to reverse the point order of the arches to make sure that the adding process goes correctly. Then here, having this, and again splitting it. So I have two different groups here. So one is a grouped version. So it's actually, here we go. So one is a grouped and one is a closed geometry. So here you can see we have our closed and here we have our open geometry with different outputs. So the one with two outputs is outputted for later skinning, and this one is input into another for loop, which just takes a group of two and it skins between them. This for loop was supposed to run over all of them, but for some reason it stops after it has done two. I'm still not very sure why, but it's a thing that happens. So in here, I use a setup that just deletes one of the modules and copies the other one over according to the total count, which happens in here, and it then gets mirrored. So if we actually go over here, you can see that the wall arches match up with this, which is also what I do here. So here just a bunch of sweeping happens. It's not very interesting, mostly just the sweeping. Placing the pillars, make a small wall segment, and then finally merging everything together. So that is the final part. Underneath here, I just had some stuff for the render setup, so it gets moved backward a little bit so that it's on the 0 axis. And then I mirror it just so I have it on two sides. Looks a bit better. In here I make a floor. So this is an interesting thing. If you input a piece of geometry into a box, it makes a bounding box logically, as the box is called, of course. And then I use some stuff to just divide it. Whoops, kind of lost my viewport there. So here I use it to, whoops, Adobe is doing something here. So here I use it to divide it and make a floor geometry. Yeah, so for the render, I wanted to copy it over a bunch so that it looks like an endless corridor, which I do in this copy. I'm not going to turn it on right now because it is probably going to spawn 100 of these. So yeah, that will be the 6th and final part of the Block C in-depth explanation videos. Thank you very much for watching, and hopefully till another video. Have a good day.